In real life, chemical energy can be transferred into electro energy using proper methods. The oxidation-reduction reaction is a great way to cause the movement of electrons. And if proper actions are taken, those electrons are able to travel through a wire and electrical current will be formed. Consider the reaction between zinc metal and copper sulfate solution. Inside the solution, copper 2 plus ion oxidizes the zinc metal to form copper metal, and zinc metal is oxidized into zinc 2 plus ion. So notice that in this reaction, the electrons directly transfer from the zinc metal to the copper metal inside the solution. They fail to travel through a wire, and therefore the energy will be released in the form of heat. So the energy is not harnessable and no electrical current will be formed. Of course, this way doesn't work because we need the electrons to travel through the wire. Now let's take a look at this model. In this model, another metal that doesn't react with copper ion, let's say copper or silver, etc., is put inside the solution. And let's use copper in this case. The copper and zinc are connected by a metal wire. In this case, yes, some electrons are able to travel through the wire and an electrical current will be formed. This is because the wire has less electroresistance, so the electrons tend to travel through the wire. However, not all of the electrons are able to travel through the wire. Experiments proved that some of them are still traveling directly through the solution. So now you may realize that as long as these two metals are put in the same solution, there's no way to let 100% of the electrons to travel through the wire. Therefore, we need to separate them into two half cells. Therefore, we need to separate them into two beakers and still connect these two metals. Introducing salt bridge. A salt bridge is a U-shaped tube that is filled with non-reactive electrolyte. The electrolyte inside the salt bridge is usually sodium sulfate gels, because sodium ion and sulfate ions doesn't react with any ions in the solution. The ends of the tubes are plugged with cotton balls. The cotton plugs prevent the solution from falling out of the tube. And the way they work is when zinc metal becomes zinc ion and traveled inside the solution, the sulfate ion will travel from the salt bridge into the solution to maintain the balance of electrons for the left beaker. It's the same for the right one. When copper ions became copper metals, the sodium plus ions will travel from the salt bridge into the solution to maintain the ion charge balance. This cell is called a galvanic cell. The zinc side is called the anode. It is where the oxidation occurs. The copper side is called the cathode. It's where the reduction occurs. Remember, the electrons always start from the anode and travel to the cathode, because the anode is where the oxidation happens, therefore it's where it loses electrons. So, a stable electrical current will be formed, and this is the most simple form of a battery.
The term galvanic cells comes from Luigi Galvani, who studied electric current in the nerves of frog legs. During his procedures, he accidentally created an electric cell when two metal surfaces were in contact with each other and to the frog leg. The frog leg twitched as a result of the induced electric current. The main application of galvanic cells are batteries. Galvanic cells are ideal for batteries because they are self-contained and portable. A battery is composed of one or more galvanic cells with reactants able to convert from chemical to electrical energy via the oxidation-reduction reaction. There are different types of galvanic cell batteries. A common type is lithium iodide battery, which can last up to 10 years. This type of battery is commonly used in computers, smoke alarms, and pacemakers, which are medical implants used to give electrical signals to correct irregularities in the heart. What about the myth of putting batteries in the freezer to extend their life? Batteries can get overheated as the electrons move throughout the battery. However, putting batteries in the freezer will slow down the movement of the ions, which can also decrease the effectiveness of the battery. Quiz time! True or false, galvanic cells convert electrical energy to chemical energy? Label which side is the anode and which side is the cathode.